Dalton's law of partial pressure says, for a mixture of gases in a container, the total pressure exerted is the sum of the pressures that each gas would exert alone. Here is a visual representation of what Dalton's law says. It says that in a container, of a mixture of gases, the pressure exerted by each gas, so say this is one gas exerting pressure, this is another gas exerting pressure, the total pressure is the combination of these pressures. And this law makes intuitive sense just thinking about it from a physical perspective. Again, going back to what pressure is force over area. And I know from physics that forces are additive. If I have a curl bar and it has 10 pounds on it, on each side, and then I add 20 more to each side, the forces are additive. I now have 30 pounds on each side, or a total of 60 pounds. And that's a downward force due to the force of gravity. Here it's the same idea, except it's over an area rather than a directional force downward. This is a force spread across an entire area. But since this gas exerts some pressure, and then this gas exerts another pressure, the total forces are added together, but the area is still the same. So that's why they are additive. It just makes complete sense from a physics perspective. But anyways, there really isn't too much else to Dalton's law. It's more just simple ideal gas problems. A useful form of thinking of it is P total, and then each partial pressure is, I can think of pressure as P V is equal to nRT, and then I can say that if I had a couple of gases and I was given everything else except for the pressure, then I could say the moles of one gas are temperature of the first gas divided by the volume of the first gas plus moles of the second gas are temperature of the second gas, volume of the second gas, and etc. for as many gases are in there. It's just more simple, ideal gas law problems with this added piece where if there's a mixture now, if I'm given the total pressure and then if I'm given these other characteristics, the moles, the temperature, and the volume, then I'm able to calculate the individual pressures. And if I'm given the partial pressures, then I can calculate any other quality that I want to know of the gases.